Thanks for joining us for the 7th session of Design Is. We're very excited to have you all here. We started this series back earlier this year in March to create a space for the design community to come together and discuss and explore the role that design has in crafting and shaping a future that we all want to be a part of. So it's great to have you here, and we've got a really fantastic speaker. I'm very excited for Marsha Haverty, who is an experienced architect from Autodesk. Previous to working at Autodesk, she created interactive data systems in the agency world, and she's currently focused on bringing to UX and design implications from ecological psychology. So we're going to have a very interesting talk this evening, and I'm very excited to have her. So with that, I'm going to hand it off to Marsha.
Great, thank you. I'm delighted to be here. So thank you, Kai, for inviting me. When we say design is immersive, I think about the fact that there's different kinds of meaning, and it feels differently to engage these different kinds of meaning. And as designers, we can actually adjust the information in our designs to dial in the right meaning mode for the situation. But in order to see what meaning modes are and properties of them, we need to look through the lens of embodied cognition. And looking through the lens of embodied cognition, we can see these invisible things about meaning. When an actor engages a design, meaning emerges in the performance of the actor acting with the design. Meaning is not a pinpoint realization. It's not a pinpoint understanding. It's a performance. Meaning emerges as an actor performs with a design. Meaning is flow, and flows have properties. And 3 of the properties of the flow of meaning that I'd like to talk about tonight are viscosity, or the ease of flow of meaning, texture, or the facets of information that are participating in the flow of meaning, and something about the dynamics of the flow, the way the actor is in training with the system of the design, or anticipating the possibilities of performing with the design. So we'll start with viscosity, and we'll look at the way we can actually use these things as design dials to tune the meaning mode of our design to suit the situation. Now, when we talk about viscosity, or the ease of flow of meaning, I like to ask, is information like water? When we think about water, its nature is very different depending on the amounts of pressure and temperature. Depending on pressure and temperature, it could be a solid, or a liquid, or a gas. What if we do the same thing with information? When we think about using language in our designs, things like text, we use labels, we use little descriptions and paragraphs and other forms of text. We now use words aloud. Our assistants are talking aloud to us. We even are starting to use gestures. Our robots and our drones are gesturing to us. But we also use perceptual information in our designs. We encode, we represent our concepts using visualizations, shapes, colors, spatial positions, line qualities, textures. We use these to infuse our concepts with perceptual information. We also use sound to represent concepts, alerts, notifications. We also use mechanical mappings to represent concepts, often also alerts and notifications, little vibrations in our devices. And if we engage language, or if we engage perceptual information, it feels very different to engage with the flow of meaning, depending on which of these we're engaging with. And that's because language is viscous. It needs our attention to flow. It's laden with awareness and associativity, whereas perceptual information, it flows easily. It's tacit, it's reflexive. We can pick it up without a lot of direct attention. It feels differently to engage with perceptual information. So when we think about designs that are dominated by perceptual information, it's a very reflexive way to engage with the flow of meaning. And when we engage with designs that are made mostly of language, it's an attentive way to engage with the flow of meaning. When we have designs that are made mostly or all of perceptual information and very little or no language, it's a very visceral way to engage. When we engage designs that are made mostly or all language, it's a very conceptual way to engage with meaning. And when we have a lot of language, it requires intense concentration. When we have a lot of perceptual information, it requires intense coordination. So if we think about reading a novel, that's a very highly viscous way of engaging meaning. We're reading the narrative of the author. We're learning new characters. We're understanding the plot. Sometimes the author has an intricate structure for the novel. And when we listen to a novel on audio, that's actually higher viscosity because it's coming at us in this cadence that we can't control. So we have to spend even more attention to engage with the meaning. These are some visualizations of the airflow and heat transfer in a hospital operating room and an airport. And we can see there's no language. We can pick up the direction of the airflow, the areas of the heat transfer just by this perceptual information. So that's a very visceral way to engage with the meaning of this design. When we engage with video games, this is a simple video game with a little bit of perceptual information where we connect dots of the same color. And we think about video games that have a lot of perceptual information and require a lot more coordination to engage. And so those are, even within the visceral neighborhood, those are very different meaning modes as well, with the amount of coordination that's required. When we think about something like online shopping, that's typically a mixture of language in the form of navigation and filters, and also little descriptions, and then product images, and maybe filters on shape and color and some perceptual things. So it's kind of a mix of viscosity. Something like an online investing site has a lot more viscosity because there's a lot of language to describe the concepts of investing and strategies, along with some of the graphs and other visuals to reinforce the ideas. When we think about something like voice UI for a digital assistant, it seems like it would be, it's very conceptual, it's all language, and it seems like it would be, a little bit lower viscosity. Simple statements, typically not very elaborate word choices. But then when we think about the need to entrain with the very specific grammar and the very specific wording that voice UIs often require in order to successfully engage with them, that is actually a much higher viscosity to context switch into that mode of that high precision interaction. If we couple the voice UI with something like a display screen to kind of help visualize when someone's thinking about options, you can only do that linearly with voice, but a display screen can help offload some of that need to keep track of the options that the voice UI is telling you about. So we can kind of phase shift if we mix our modes a little bit there. So I think the key thing I want to say is that viscosity is not inherently good or inherently bad. It's a design dial that we can use depending on the situation. Sometimes we want low viscosity, and other times we want to slow it down and have higher viscosity. And I also want to point out that ease of flow is not about being easy or difficult. Learnability, usability, accessibility, those are all important things, but that's not what this is getting at. Ease of flow is about the kind and quality of attention that's required to engage with the meaning of the design. So let's think about a digital agent. This digital agent goes off and does things autonomously on our behalf. And inevitably, the agent will need to come back and give a status update. So what's the right viscosity for that? Maybe there's a little perceptual haptic pattern that the actor can feel on her skin and pick that up without distracting her from the conversation she's engaging in with a colleague. Maybe that visceral understanding is enough for a status. But maybe when there's an important finding or a critical decision point that needs the actor's attention, we can use a higher viscosity to draw that attention in. And we can use all of our designer tricks of progressive disclosure and summoning more details on demand. We don't have to drop a big glob of honey on the actor all at once. We can have a little bit of language and then bring that in if the time is right. But the idea here is that within a particular design, we might phase shift within viscosities to support particular activities within a more complex interaction. What about a self-driving car? What viscosity makes sense to engage with a self-driving car, with the passengers? We can think about voice UI, saying, hey, also go to the bank, take a more scenic route. There's some quick things that might be nice for that kind of viscosity. But when we think about driving and we think about some of the critical decision points that the car might need to summon from the passengers, maybe as we look at those concept drawings of those lounge chairs with the coffee table in the middle, maybe that coffee table also needs some kind of interactive visualization of the situation of the car with respect to its surroundings, so that the actors, instead of the car having to translate into language a very complex perceptual situation, it could visualize it. And the actor maybe could even go in and just tweak positions on the visualization. So we don't have to phase shift to language. We can keep it visceral to suit the situation. So that's just saying perceptual aspects of driving, maybe we could keep that perceptual aspects of engaging as well. And we don't always have to phase shift to language. So that's a little bit about viscosity. The next aspect of meaning modes I like to talk about is called texture. And we already looked at this. So we looked at some of the forms that language can take. We looked at some of the perceptual information we can use in our designs. And that's about the information mode, how the information manifests in our design. But we also need to think about how the actor goes about interacting with the information. So the actor could simply look, read some text, watch something. That's a way of interacting. The actor could enter some text, searching or engaging in some sort of dialogue. The actor could talk aloud to engage with the design. The actor could gesture to a physical object or a simulated object. The actor could engage in a visual spatial selection, just a fancy way of saying our good old graphical user interface, where you're deciding where to click or press on a button or interact with the other elements that the designers have added. Or the actor could simply be listening to a description or a newscast or whatever it is, the content. And then the actor could also be engaging in something a little bit more taking place in real time, in space and time. So something like drawing, sketching with 3D, with light. The actor is actually where she is walking around in physical space is the way she's engaging when she does this 3D drawing. It's her physical place and her motion that is the way she's engaging with that drawing. And same thing with the sculpture. That user is using this wand to move around as if that simulated information actually occupied space. And there's haptic feedback, so he kind of knows where the surface is. So that's another way that we're able to engage as well. So when we look at these facets, especially for more complex activities, we have all these different permutations available to us as designers. Maybe our information shows up as text and the actor can either enter text or talk aloud to it, depending on the situation. Maybe there is a sound and the actor might gesture to react to that sound, and then there's some visualization that keeps track of the history of that over time. And all of these different permutations. It's hard to imagine some of these combinations, something like, how do I interact with text by physically walking around and engaging with it? I actually saw a technologist artist create something exactly like that. So we won't discount any of those permutations. I'm sure someone's experimented with virtually all of those. But let's look at how this plays out. So let's think about a driver adjusting the comfort settings in a car, and let's focus on visual information. So the driver is relying on a lot of visual information streaming through the windshield in order to keep the car in the right place, heading in the right direction, and not hitting objects in the path. So there's a lot of visual information going on. And if we think about a typical dashboard control panel, that's usually a combination of text and visuals, maybe a little bar chart or meter, and then some labels and places to press buttons on a graphical user interface. And that also requires looking and scanning using visual information. And actually adjusting the controls also requires looking and scanning to place your finger in the right visual spatial location. So something like a touchscreen control panel actually disrupts the critical visual information for driving a car. So we say, okay, fine, we'll use voice controls. We'll save vision, we'll use voice to control the settings. Now, voice, as we discussed, has a little bit higher viscosity, but that's fine. We're reserving vision for driving the car and not hitting things. But we also have other uses for sound information in driving a car. We're listening constantly for sounds about events in our surroundings. Some kid running through, we hear them running. We hear a car braking. We hear a motorcycle coming up. We hear a train, a dog, things like that. And we're also often engaging in sound with our conversations with our passengers. They're the words that they're saying, and we're listening and we're projecting words to them to engage in a conversation. And maybe we have the radio on, we're listening to the news. We've got a lot of high viscosity activities going on where we're engaging sound. So the voice UI also disrupts those other important things that we're doing with sound. So that's just an example to say that we don't want our texture facets to disrupt and step on each other. We want to make sure that they're harmonized across the whole activity, enhancing each other or offloading something from one another. So we're looking for this harmony in the texture of the flow of meaning. So that's a little bit about texture. Now I want to talk about some dynamics in how the actor is engaging with the performance of the system, actor and design. And the dynamics that I want to focus on are how the actor is in training with the design and how the actor goes about anticipating possibilities for performance with the design. So we'll start with in training. In training is about how precise must the action be for the actor to successfully engage the design. So again, I'm kind of picking on car panels, but it's a good example. If the driver is engaging a display panel in the dashboard, the driver probably has some muscle memory for about where to touch to adjust the temperature. But in order to actually place her finger on the exact spot, she has to be fairly precise in the location. And again, in this next screen, she probably has some muscle memory for about where to go to set the temperature up or down. But again, she has to be pretty precise to actually place her finger in the control to raise the temperature or lower the temperature. This is a concept design where we have a blank screen and the driver places fingers anywhere on the screen and the UI comes to that place. And then the driver moves her hand up or down to control the setting. So when we think about the precision to entrain with the system, to actually perform with the system, something like a more traditional graphical UI control panel has a very narrow tolerance for imprecision. You have to be really precise spatially to actually engage with the meaning of controlling temperature in your car. Something like that prototype control panel has a wide tolerance for imprecision. You can place your finger anywhere on the screen. As long as you're going roughly up and roughly down, you're engaging in the flow of meaning of controlling your ambient comfort of your car. So that's really forgiving. So back to this scenario of adjusting the comfort settings in a car. This prototype blank screen summoning touch control panel has a very low viscosity. It's a very visceral way to engage with the flow of meaning. And it also has a very high tolerance for imprecision. It's very forgiving. And it uses haptic facets. So it harmonizes with all of the other facets that are used in the overall activity of driving a car. And I'm not saying we all have to design it like this. It's just an example of one way to harmonize these facets. But when we think about other aspects of adjusting comfort settings, maybe that haptic put your finger on the display panel would work well for turning on the radio or off the radio. But if you want to play a particular song, songs are referenced by language. And so maybe using language is the best way to then engage with the song. So maybe a voice UI would be the best way to say, hey, play this song. So the point there is to say maybe one mode isn't the right thing for all of our comfort settings across a car. Maybe putting everything in that one panel or everything in voice UI may not be the right way to harmonize across the activity. So we talked about tolerance for imprecision, and we were talking about engaging in a visceral way, but language also has tolerance for imprecision. So if we think about voice commands as they are now, there's a narrow tolerance for imprecision. You have to use a particular grammar, syntax. You have to use particular words to engage with the meaning of the system. When we have things like natural language processing, that's actually increasing the tolerance for imprecision. And then something like machine learning of a particular user's syntax and wording increases the tolerance for imprecision even further. So we can see language also has that notion of precision. But again, just like viscosity, tolerance for imprecision is not inherently good or inherently bad. It's a design dial to use for the situation. If we think about something like coding, computer programming, that is a very precise way of engaging with information to have a meaningful experience with programming a computer. And we should embrace that as designers and scaffold that precision with things like, color coding and all of the other wonderful things that have been created for coding environments over the years that we've been doing this. So that's an area where we want to embrace the need for precision and scaffold for it. So that's a little bit about tolerance for imprecision. And another aspect of dynamics is about the actor anticipating the possibilities for the performance with the design. And that's really about how much autonomy or intelligence does the design bring to what's possible. So we think about the actor engaging the design and meaning emerging as a flow during that performance. So when we think about over time, the whole domain of all of the performances that are possible with that design. I mean, one actor is never going to engage in every possible permutation of that, but we can kind of get to know overall the nature of the design and the nature of what's possible to perform with the design. We get to know it. We have a sense of it. It feels a little bit stable to us. The actor actually engages in this tension between anticipating what's possible and then actually aligning with what's actually happening as the actor is engaging and performing with the design. And it's this nice creative tension that becomes a balance with an actor and the design as a system. But when we are introducing things like machine learning in a domain in which the machine learning actually brings back richer, more nuanced, more fine-grained understanding of the domain, machine learning across domains where there's now new associations between this domain and others that we didn't know maybe were related. And then things like computational assistance, where an actor specifies some preferences and the machine actually goes out and creates a whole bunch of permutations that suit those criteria and brings that back as new information. Things like this are actually injecting a little bit different nature to the design. It's changing the nature of the design. And so instead of this balance between anticipating what's possible and aligning with what's happening as the actor is engaging in the performance, the ability to anticipate is much less because there's a lot more aligning as this nature of the domain is changing with this intelligence, new information, new discoveries. So we can say that there's some dynamics in the space of what's possible. And again, just like viscosity, there's not inherently goodness to a stable system or goodness to a system with machine learning and volatility. It's a design dial to use for the situation. So we can think about stable systems have nice qualities. They're repeatable, they're knowable. We don't go through and do every possible performance, but we get to know it and we know what to expect from it. And then when systems are volatile, the nice thing about that is there's serendipity, there's discovery, there's a newness when we approach that new information, and this nature is constantly changing, and we're aligning with that. There's good situations to use that as well. So for dynamics, we have tolerance for imprecision and thinking about possibility space dynamics. And that's to say, we don't want machine learning on everything. There's some situations where that's really beneficial, but other times we want a stable system. And sometimes we want a high tolerance for imprecision when someone's distracted or engaging in a lot of different modes of information. And sometimes we want very high precision. We want to embrace that. So that's a little bit about some of these aspects of the flow of meaning that we can actually dial in as designers when we make decisions about the information in our designs. And we can actually facilitate particular meaning modes that will suit our situation. Thank you.
So when you're talking about the volatility vis-a-vis machine learning, that didn't really make sense to me in that it seems to me that as the machine learns what behaviors to anticipate or what behaviors you like, that would actually stabilize your interactions with the design.
Yeah, well, that's actually an interesting discussion point, because maybe some machine learning is actually getting to know you. And so it's making the interaction more stable for you. So maybe that's more about tolerance for imprecision. There's other applications of machine learning are sort of going out and saying, oh, there's this aspect of some other domain that relates to what you're trying to do in your domain. And so that's new information. So I think using the term machine learning maybe is a little misleading, because it totally depends on what kind of machine learning and what you're applying it to. So I think, as that example in the tolerance for imprecision, when it's machine learning about a user's syntax and wording and habits and behavior, that actually probably makes it a more stable system. So yeah, that's a good nuance. Yeah.
I'm thinking about different learning styles. So auditory learners, visual learners. How does this sort of like take those different learning styles into account? Like what implications are there for a user's learning style? So if you're more of a visual learner, for example.
I think learnability in itself is a whole separate topic, but I think this could play into that, and maybe dually encoding information in, auditory, visual, whatever the 2 or 3 modes are. I think that could then, learners could choose which one is suited to them, for sure. Another aspect of this that's really important is accessibility, right? Because if you encode everything in visual information and people have low vision, they can't engage it at all. You need some other mapping that's going to play into that. So I think you could use viscosity to enhance if people have a predisposition, or maybe your design could let them, hey, more of the visual or more language. Yeah, thank you.
Thinking of the automobile and the dashboard and the controls and accessibility. If you think about a pickup truck, it's designed for working people with gloves on and imprecision of adjusting things. Yet somehow we've convinced ourselves we want the full touchscreen of the Tesla.
Yes.
How did that happen?
I don't know. I don't know. I see the screens getting bigger. I'm like, I'm trying to drive. I don't know. I don't know. I guess we're anticipating the self-driving cars.
Do you have an idea that this might connect to a design system where these would all have a language that could come out of it, and you could start using a system with certain modes based on your meaning modes having different systems associated with each one?
Absolutely. Yeah. Classifications and systems, of course. Yeah, for sure. And actually, there's one thing I didn't get into, but when we start thinking about, we're now engaging sort of physical and digital objects. And when we cross into engaging objects that take up space with us and are part of our surroundings, that's a whole other aspect of meaning modes that's really important. And now we're engaging affordances, and that's even a different kind of engagement with meaning. So yeah, I would even go further and say things that are conceptual have their own sort of system of classification across all these modes, and then things that are physical, even if they're simulated, if they're taking up space and we engage them as if they're objects in our surroundings, I think there's a whole system around that too.
Thank you for your talk. I have a quick question. I use Autodesk products every day. And I just wanted to, can you speak to some of the work that's translating over to Autodesk?
Yeah, well, some of the things that we're thinking about, so Autodesk makes 3D CAD software for engineering and architecture, media and entertainment, things like that. And 3D CAD, there's a lot of perceptual information there. So our users are in that area of the phase space for sure. Lots of perceptual information. And one of the things that we're thinking a lot about is, especially on these bigger projects, they're collaborating with others. And these others aren't necessarily sitting right next to them. And when you're collaborating on this giant piece of machinery and someone's making a design change on a part that's going to impact your part, you want to know about that. And so we're thinking a lot about what does it look like to kind of interrupt this flow of a very perceptual way of engaging meaning and, say, hey, there's a change being made. Can we cue that with perceptual information and sort of phase shift them into language as we need that? So something I was working on a few years ago, we were looking at that. So that's an example.
You might want them to be phase shifted very quickly, right? I mean, you might not want it to be this sort of gradual thing. You might want the alert.
Yeah, exactly. Yeah, so it's I think, again, with the classification, can classify everything. Classify sort of the sense of urgency on the range of viscosity too. Yeah, and I guess one point that I want to make too is something like viscosity is unique to the individual. It's not like this absolute scale. It's something that is very visceral and requires a lot of coordination for me is different than for you. So we have our own scales and those change. Yeah.
Nor is there purity really in that.
What's that?
Nor is there the purity that you're presenting is obviously not.
Every map is a lie. Absolutely. Yes.
Like that.
Surveying the landscape of design, do you feel that there are modes of meaning that are either underexplored or do you feel that there are other modes of meaning that are overpopulated? Where are you seeing the errors and where are you seeing the opportunities?
Well, I mean, it's not for me to make error statements or value statements, but if I have a world where I engage with voice UI with everything, that would make me really sad. And I feel like there's times when I want to do things quickly, tacitly, viscerally. Can I do that? Can we design something that's not always a little, sound alert visualization, but then it always shifts to language and there's a notification in words? Can we actually engage with something that's fully perceptual? That's one area that I'm looking into.
So then a related note, you reference embodied cognition early in your talk. Mm-hmm. And are you seeing embodied cognition as kind of shorthand for that more visceral mode of interaction?
Not shorthand for that mode of interaction. I mean, that just is the way humans are. But I think it's the lens by which we say people engage with meaning. So ecological psychology, which is started in the mid-century, actually thinks about cognition in a different way. So traditional cognition is our senses take in stuff and our brains do all the work to process that, represent it, and decide meaning and decide how we're going to act. And then our action is an output. And embodied cognition says we actually engage with information directly in the environment. We don't have to process it and represent it. And that's a very different way of thinking about engaging with meaning. So whether it's perceptual information or language, that's not really the distinction with embodied cognition. It's saying that we don't have to remove ourselves from our physical surroundings to say that we're actually part of our surroundings, and it is our action in our surroundings where the meaning emerges. So it's just a different mindset, I think. I don't know if that explains. I'll use a picture.
It seems to me that the age of the people using these systems might have some influence, because I'm old enough that reading text flows like water, and interpreting little symbols and icons and things, sometimes I look at it and I say, just use the word,
Yeah.
and that although I think our whole culture is going much more to the non-textual, I think there's always still going to be some people who just love text and who have a gift for it and are really focused on it.
Yeah, I mean, I love language too. And I think, I mean, for the icon thing, you know, the dual encoding of the label and the icon, things like that. Yeah, it's really interesting. And I don't know that we've explored a lot with how do I actually just engage with visual information, or, you know, moving around. I convey my intent just by moving a shape around or changing a color or something, you know, instead of engaging language. But I think it's sort of an area to explore and a muscle to flex. But yeah, it would be interesting to know if, because we grew up in a time with so much language, that we're more predisposed to it, and we have a whole different viscosity chart because of that. Yeah.
Thank you guys all for coming, and join us next month for Design is Emotion. We have Pamela Peveslok coming, and you can also check out previous talks on our YouTube channel, the Google Design YouTube channel. So thank you very much.